are you aware what is machine learning? That's the first question. And why machine learning is required? That's the second. And third is, do we always need ML? That is the third part. So yeah, if you can maybe just write it on the chat, that would also help. That do we always need ML? That is the first question. And let it be very interactive. I'll just wait for maybe a couple of seconds and then I'll just tell you what I think about it. So for everybody else, if we are talking about ML, the first question that I'm asking is, do we always need ML? That's true. We don't need ML every time. Now, so even if the problem is complex, it shouldn't be that machine learning can solve it. You should always go via traditional approaches only when you find, okay, this is complex enough and there are certain conditions towards it that we'll discuss. Based on that, a problem can come to a machine learning domain. Not all problems will come inside machine learning domain. That we need to be very clear of. Okay, this is the first point. Okay, now the second is, how should we know that a problem given use case, and in the entire series of session, whenever I say a problem, I am talking about a use case. So for use case, for an example, let's suppose that we are building a classifier. A classifier is something that once you give an image, it will tell you if it's a cat or a dog. Very simple binary classifier. Okay. So these could be a use case. So whenever I say use case, this is a specific use case. Okay. Now let's suppose you specifically know how to get an answer. Okay. So let's say we have a table. Okay. We have X, we have Y. Okay. Y in this case would be something that you would need an answer for. So this is the answer. This is the answer that you're looking for. Okay. And in terms that what you have usually seen, this is a function of X. And in the end, we want to achieve Y. Okay. We want to get Y. Fine. And I will be using very simple terms so that everybody understands it. If I start using mathematical terms, or maybe if I start saying those notation, let's not get too complex. Let's start from the scratch and let's use basic terms. So if I'm saying this is my answer and this is my function. Now, if suppose let's keep it very simple. This is 2 and this is 4. This is 3 and this is 9. This is 4 and this is 16. If this is the table given to you. Now the question is, should you use machine learning to solve this? What is the question? Question is that what given X, what would Y be? That is the question. That's a very simple question. And you have been given a table that when X is 2, Y is 4, X is 3, Y is 9, X is 4, Y is 16. Given this, would you use machine learning? Now, this is the very simple question. So it could be any problem. Now, this is one problem. Now, the point is, because we know this is just a square function. So the function that we are using, we are just squaring. So whatever we are giving X, we are just squaring X. Okay. When you exactly know how to achieve this Y, at that moment of time, in those problems, you shouldn't be using machine learning. Because machine learning should be used when you don't know how to achieve Y, when you exactly know the function to get to the Y or get to your answer, those are the problems which you shouldn't be using. Those are the problems for which you shouldn't be using machine learning. Is this part clear? So I have taken a very simple example that when you exactly know how to go from one state to your goal state, exactly know, those are the problems where you shouldn't be using machine learning. This is a very simple problem. You should be using a square function directly. I hope this part is clear. Why is machine learning required? So similarly, if suppose we have another table and we have Y here, okay, and we have X1, we have X2. Why do I represent it as a table? Because usually when you see a data set, it is represented mostly like a table. And let's suppose if we talk about our data set, we usually see labels, right? Or maybe something. So let's suppose this is our table. Now, if x1, 1, 1, 2, 2, 3, okay. If this is the table given to you, and let's say y is 2 in this case, 3 and 5, okay. If this is a table given to you, would you solve it using machine learning? Will you ask a model that given two variables predict y? Would you do that? You can chat on, you can just post your answers there. No. So that should be straightforward. Why no? Because here in this specific problem, we can see given two features, y is just a summation of those features. That means we exactly know how to reach this state. And whenever we exactly know, those are the problems where we shouldn't be using machine learning. This should be very clear. Now, if I have some more signals here, and if I don't know that how to calculate y based on those number of signals, those are the problems which come into machine learning domain. Okay. This is the crux, that when should a machine learning model be even trained? This you should know. Otherwise, what would happen? Any simple problems, you will start using machine learning algorithms to get to an answer, which might not be very precise. Because the problem is, can you train a model with this data set? You can post your answers on the chat. That's the next question. Can you train a machine learning model using this data set? And data set would be given two signals, X and Y. So these are the two features, and this is your Y. Can you train a machine learning model? Yeah. So what I mean to say is this: we have only three tuples, three rows. Let's say we have 1,000,000 rows here. If we have 1,000,000 rows here, can you train a machine learning model with this data set? In the initial stage, I am keeping the session more interactive so that there are some questions in your mind, those should arise. Only then we should start the session. So that's why I'm asking so many questions. Okay, yeah. So the answer is correct. Yes, you can train, but should you train? That is the most important part. You shouldn't be. When you already know the function, that it's just a summation, why do you need to train a machine learning model? Because machine learning model, when it gives the result, it's not precise. Using a function, if it's a summation function, it's exactly 2. But if you train the model, it will not always be 2. It could be 1.95. It could be 1.99. So it would be very close to 2, but not exactly 2. So now I am coming to the next part. Machine learning algorithms should not be used where you need exact answers. This is also very important. So if suppose you are on a project and you want exact answers, very basic example is that given 2 plus 3, if you are writing in an exam, and if you have to write 5, you cannot write 4.999. You will not be given marks for it. That means anytime you want exact answers, that time you shouldn't be using, or you should be using some post-processing technique to get the exact answer. Okay. So whenever a machine learning model is giving you a result, it's not always very exact. It is very close to the answer. It's not exactly the same answer. So I've given you some brief idea when to think about using a machine learning algo. Because nowadays what people are thinking, that any complex problem, just get the data set, train with the model, and you will get some answer. But it's not always true. You will definitely get some answer. The training would always happen. But should you be even training? That's the first question you should ask. Should this problem be solved using a machine learning algorithm? If you can answer that, only then try to use machine learning techniques. Okay. I hope this part is clear. Okay. Now, if this part is clear, now let's start the actual session. What I wanted to cover. Okay. So let's define machine learning. So formal definition of machine learning, so I'll quote one of the authors of a book. So that's Tom Mitchell. You can actually search his book. That's Machine Learning. Name of the book is Machine Learning. It's a really good book. It talks about a lot of topics, and it's from the scratch. You will get to know a lot of things. Yeah, the book, it's very detailed. So if you have time, only then go through it. Otherwise, you can read parts of it. So based on that author's definition, a computer program is set to learn from experience. So when I say experience, I will note it down as E. So a computer program is set to learn from experience. Okay. Experience E with respect to some class of task. So whenever I say some task, it could be any task. For our sessions, let's consider few very simple tasks like a binary classification. Given an image, classify it as a dog or a cat. Okay, let's make it very simple. Class of task and performance P. Okay, so now based on the definition, we have experience, we have a task, and we have a performance. We have perform. Okay, now if the performance improve over time of this particular task using our past experience, this is what machine learning is. So definition of machine learning is that our performance should increase using the experience that we have gained for any task that we are doing. Okay. This is the formal definition of machine learning. I hope this is clear. Now I will give you another definition. So it's the next definition is from Andrew Ng. I hope you are aware who Andrew Ng is. So the fundamental course that he started on Coursera, that's the machine learning course and the deep learning course. You should definitely go through that course because that's the fundamental course that anybody should be learning in the first bit if they're starting from scratch. Okay. So how Andrew Ng describes it, he says, it's a science of getting computers to act without explicitly programming it. Now, what do you mean by explicitly programming it? Now, if it's a classifier, okay, let's suppose this is our model. Okay, whenever I say M, so let's suppose this is a model. Now we are giving an image. So I will denote image as I. Okay, we are giving an image and our model is saying it's a dog or it's a cat. Okay, this is fine. Now, what it is, what by the definition, what it is saying that we don't need to explicitly program everything inside the model. That means given an image of a dog, I don't need to write rules, exact rules for this model to work so that it can perform a task of classifying a cat or a dog. Okay, so that's machine learning. I hope these two definitions are clear. You can actually go online and check these definitions and get to know what exactly they mean. But these are the two definitions that I wanted to cover to understand what is the formal definition of machine learning. Okay. I hope this part is clear. Anywhere in the entire session, if you have any doubts, you can start writing it on the chat. I'm monitoring that as well. So if I see any doubt, I'll clear it that time itself. Okay. I hope till this point, everything was basic. So I don't think so. There should be any doubt as such. Okay. Okay, now if that is clear, and we have already seen one more thing. What we have seen? We have seen that given a problem, we had an X and we wanted Y. So what we were actually doing, we were actually trying to compute this. This was our initial examples. Okay. Now, what do we do in machine learning? Machine learning, we are doing something very similar. So when we talk about this, we have data. Now, there are a lot of data sources. So if you talk about data sources, everywhere you see. So if you're using a phone, you are generating data. If this entire video presentation, right, the session. So we are recording it, we are talking, everything is generating data. So we have a lots and lots of data, right? It could be different domains, but we have a lot of data. Now, using this data, we would be feeding to an ML algo. Okay. What is the goal? Using the data, we would be feeding that to the ML algorithm. And what does the ML algorithm return? It is trying to identify a function. That's it. That's the entire goal of machine learning. Now you can call it a function, you can call it a mapping function, you can call it anything. But this is the entire goal that you would be doing in machine learning. And any technique, I can say any technique that you're using, you might be using different complex models, but indirectly, what you're trying to achieve is given enough data to a model, we are trying to find a function. That's it. As simple as that. As soon as you find this function, that's more than sufficient. As soon as you find that function, anytime new data comes in, so if you say new data, I will say X new data comes in, you will get a Y, and this is your answer. And this is what you're looking at. You just need the answer. So the entire training process, what you train is just to find this mapping function. As soon as you find the mapping function, you're done. So I will come back to the example. So what I said, as soon as you find the mapping function, it's done. So if you already know it's a squaring function, right? You're just squaring it. Then you don't need to train the model. You already know this function. When do we train? We train when we don't know this function. If you already know the function, you don't need training. Start directly using this function. I hope this part is clear. Okay. Okay. If this is clear and you don't have any other doubts, let's continue. Now the second part would be, in the entire course, I would be giving you geometric intuition, because I feel mathematical formulation or mathematical notation, I will definitely give you that as well. Mathematical formulation and notations are good, but once you understand something geometrically, that is more intuitive. Once you understand what a model is doing geometrically, you will remember it lifelong. And then you can map that understanding to your mathematical concepts. That's totally fine. Okay. If that is fine, let's discuss one more thing, which is very important to know when you are starting with ML. Okay. Now, to be honest, in today's age, everybody is talking about machine learning, and people talk about machine learning, deep learning, AI interchangeably. For the most part, it is fine to use these terms interchangeably. But as a machine learning engineer or as a data scientist or as a student in this domain, you should exactly understand what is the distinction between this. Okay. So let's suppose we're talking about AI. Okay. And I'll make sure that this is the circle and this is AI. Okay. So this is the entire circle where we can say this covers all the AI models or anything related to AI. When we say machine learning, okay, once we when we start saying machine learning is a part inside AI. So I can say ML here. This is machine learning. So there are a lot of things. There could be a lot of things that are present in AI domain, but not as part of ML. This distinction should be very clear in your mind. You cannot interchangeably say ML related things and directly. So you shouldn't be confused between AI and ML. There could be a lot of things that are present in AI as such, but might not be present in machine learning domain. Okay, that's the first thing. Now, what about deep learning? When we say deep learning is another internal set inside machine learning. So when you say deep learning, it is indirectly you're saying talking about machine learning. What is deep learning? Deep learning is a specific range or specific set of models which use neural network. So these are a specific set of machine learning models which use neural networks. So anything outside this space could be anything, but anything inside this space, this deep learning area, if I say this is deep learning, would be using a neural network. I hope this distinction is clear. Most probably, majority of you would already be knowing this distinction, what AI, ML, and DL means. But this should be crystal clear in your mind. As soon as somebody is saying deep learning, you should be aware that which quadrant or which space you're talking about. Okay. Any doubts till this point? If there are none, then we can continue. Okay. I hope everything was fine. So let's start. Okay. Now I have given you some brief idea what ML is. I have given you some brief idea what we are doing in terms of what is the goal. So let's talk about the goal once again so that we are on the same page. And then I will give you a brief idea to understand how to get to a point. Okay. So let's do that. When I say data could be anything. Usually we when we talk about data, we think in terms of there's a label Y and there's X. X could be there could be n number of features. Whenever I talk about data, you should imagine this table in your mind. Let's just to keep it simple, imagine this, and this X could be We can say x1, x2 to xn, and we have a label y. We'll discuss supervised, unsupervised later on. But whenever I say data, imagine this. Okay, let's be very clear about it. What we are trying to do, we are using this data and we are giving it to a model. Okay, and what is the model doing? It is trying to get a mapping function. Okay. Now I mentioned that anything that I would be talking about I would be giving a geometric interpretation so that it's much more clear and intuitive. Okay. If that is true, let's see. So let's suppose we have a graph. Okay. And let's suppose we have data points here. And these crosses are data points. Okay. These are the points. So these are the data points. So when we were talking about this data, these data points, X and Y values. Okay. So given, yeah. So these are the X and Y values. So if I say X, this is the Y. Okay. This is the same data set what we are talking about. So if I talk about this, we can imagine it like this. So given a value of X, what is the corresponding value of Y? This is what we are finding. For any point over on the screen, given a value of X, this is the X value. Okay. Given X, we are trying to find what is Y. This is the entire goal for a very simple algo. I hope this part is clear. Okay. And if this is true, let's try to find out this using a machine learning model. And because this is the first session, let's try out a very simple model. And looking at the data, yeah. Any doubt? Okay. So looking at the data, I feel we can fit a simple line here. So let's try to fit a line. Okay. This is our line 1, L1. Okay. This is the first line. But do you think this L1 is the best line? It might be a good line to fit in. It might not be a good line to fit in. And whenever I'm saying to fit in, what do I mean by that? I mean by that is what I will do once the line is trained and it's fit. Okay, once the line is done, the fit part method is done. We would have this line, and anytime I will have a X, anytime that I will have a new X, I would be using this line to identify my new Y. Okay, so this is what I mean, that is this the best line to give a new Y corresponding to a new X? It could be this line, it could be this line, it could be this line, and there could be n number of lines. Okay, so I will say L2, L3, L4, L5. And when you say a machine learning algorithm or a machine learning model, let's be very simple. This is a normal line, and this you can consider it as a machine learning algo or machine learning model. Linear regression. So when we talk about that, we'll talk about that. But this is a very simple line, which is giving you a mapping function that whenever you have a new value of X, it is giving you correspondingly a new value of Y. I hope this part is clear. Okay. So are you sure now what the goal of ML is? So the goal that you're doing, the training part. So the goal is to identify, there could be n number of lines over here, right? The goal is to identify the best one among these so that whatever Y that you wanted to get or whatever Y that you wanted to achieve is as close. I will emphasize on it should be as close as to the answer that it can be. Will it always be exactly to the answer? It won't be. It should be as close as possible. Okay. So now did you get the entire goal? So this is very important and this should be clarified in the first session. What is the entire goal of all the sessions, of all the models that we would be talking about? The entire goal is based on the data that we have. We want a mapping function which gives us the y value, which should be as close as possible to the final answer. Okay, is this part clear? If it's not clear, tell me. I'll again repeat it. I'm keeping everything very simple so that you understand what machine learning is, because these are the basics which might not be covered in introductory sessions or maybe in some books as well. So you should understand what is the entire goal of machine learning, what you are trying to achieve when you are using a machine learning model. Okay. Now, if this is clear, so my next point, I'll definitely talk about the linear regression part in detail when we are talking about linear regression. Okay. But as of now, we should understand that given two machine learning model, our goal. So if suppose this is one line and this is one line, this is L1, this is L2. Our goal is to get the best line. Okay. Now, how would we identify the best line? Let's suppose for okay, let's take one example. So for this point, for this x new, okay, for this x specifically, okay, are both the models giving different outputs? Okay, this is y1, this is y2, or I could say y2. Okay, so L2 is giving an answer y2 and L1 is giving an answer y1. Okay, now both of them could be very close to our answer, but just to identify which line I should be using finally, what we could do is we could simply calculate how far our answer is. So if suppose our final answer is let's say our final answer that we are talking about is the answer. This is the final. Okay. And let's suppose our final answer, I would just say y. Okay. Y final. Let's keep it very simple. This is the final answer. So what we are trying to achieve is we got y1 from one model, y2 from another model. What we want exactly is y final minus y1 should be minimum. We need to minimize this. Is this part clear? I actually read what about data science. I'll cover that later on because I wanted to focus more here. This is the crux of the today's session. So I wanted to focus more here, then we can discuss that. But is this part clear? What we are trying to achieve? You can post if there are any questions. So what we did, this is the y final. This is the actual, this is the correct response. And this is the response from the model. What we are trying to do, we are trying to minimize this in a way that this y final and y from the model should be as close as possible. And when we say you are minimizing something, this is what minimization means. I'll tell you exactly what minimization means and what we do and how do we achieve it. But this is the end goal. Okay. Now for the second model, I have y final and y2. So if I'm just comparing these two values, and if I say this value is much, much lower than the above value, then can I say my y2 model, that is the line 2, is better than L1? Any doubts till this point? I know it could be very unorthodox, the session. It is not starting from what ML is, what are the algorithms, what is the supervised learning, what is supervised learning, what is unsupervised learning. But this is something that I feel should be covered and should be understood really well before even talking about those terms. Any doubts in this part? Okay, so I hope this is clear. Now for a line, I am talking only about one point here. It could be n number of points, okay? And if it is n number of points, then what I can say that I can just this part. I can just, this is the difference, right? I can just try to summarize my y final, and y2 is given by our model. Okay, what I can do is y final would be something, I can just write 2 here and y final here. Why am I writing here? So that we know that this is coming from the data set, or we actually know these values, and this part is coming from the model. Okay, so if we know this, we can just say I, so that we are just iterating over for all the points from 0 to n. I told you I will give you the geometric interpretation as well as the mathematical. So this is the mathematical part of it. So what we are trying to do for all the points from 0 to n, we are just trying to sum up this difference. And as soon as we sum up the difference, so for L1 and for L2, let's say sum for L1, I'm keeping it very simple. That's why I'm writing these numbers. It could be anything. For let's suppose this is 100 and this is 150. What do you understand by these numbers? First of all, that is my question. Because you should understand what this 100 and 150 mean. Do you understand this? You can just type yes or no. If there are majority of no's, I'll cover it again. If majority of them are yes, then we can continue. Okay, so yes, okay. Points in L1 case are closer and a best fit. Yeah, okay, so you understood it. So this is what we are trying to achieve. And this is how. Now, this is not the appropriate loss function, I would say. I'm using such terms which I shouldn't be using as of now. When I say or when I cover loss function, only then I will be using it. But given these, now you understand how do you select a good machine learning model. So given this is the difference, right? And when we say the difference, this is a summation of difference of all the points. And what we wanted to minimize this. Okay. When we wanted to minimize this, that means these values should be as low as possible because these are the differences. That means our L1 model is better performing than L2. So I would say this is better. This is a very small example. There are a lot of complexities which I've hidden, but just for this, keeping it very simple, I will say L1 model is better than L2. Why? Because majority of the predictions are much closer to the actual value, and that is why the summation of the differences or the loss, you can say, for this case, difference is higher. Don't we take the square? Huh. That's the correct point. Now, this is one point. You have asked me, don't we take a square of difference? Why do you take a square of difference? I'll definitely cover when we are talking about that. You are thinking in those terms because you are reading it. Fine. You have read because you're taking square. That's why you're thinking that why didn't we take a square? You should know that is taking square the best method? Should we take squares or should we take something else as well? Okay. Yeah. So I hope this part is clear. And just because that question came up, I'll just talk about that as well. So what we have done, we have just taken a difference. Now there's certain issues with this. When we are summing up, right? And when we are summing up these values, okay? And what we are trying to achieve, we are trying to achieve minimizing it. Okay, we are minimizing it. It could be possible that a certain value, this value is 10, this value is 9, but this certain value is minus 1000. Because my model figured out that if I give a very extreme negative value, it will give minus 1000 and the summation would automatically come down to a negative number. And if that is the case, what you would feel that L2, if suppose there is an algorithm L3, it is giving a value of 5. So would you say this L3 5 is the best algorithm? You cannot say that. You don't know what L3 is giving. L3 is giving 5 because it is giving an output so negative that your entire thing, for all the other points, it was much higher. But just because of one point, it came down to a very lower value. And you feel that L3 is the best algorithm. And that is the reason what you pointed out, right? Why do we square? We square it so that these cases shouldn't arrive. that we don't start using those values because we see just one point is changing the entire directionality of the way we are thinking. Okay, this is the first point. Now, my question is, why did you even think of square? So if you can answer that, because I want it as an interaction, that's why I'm asking. Why did you think of a square? Did you want to make it positive? Always. That's my question. So I got your point. So anybody who's not understood what the question was what I was doing. This was the final and this was the model. Okay. I was just taking a negation of this. Okay. The suggestion that was given to me was square. So my question is, why should I do a square? Do you want to make this positive? That's my question. Just to make it positive, are you using a square? Okay. Others can also interact. Others can also say what they feel. And I'm keeping it more interactive so that you think while the session progresses. Because if you're not thinking, then you will not know exactly what you don't understand. Okay, you don't have to type the entire thing. You can just give a brief contextual idea, just brief your thought process. So that's true that Square could make this possible. Actually, I have read this description. Got it. Okay. So Square could make this positive. But do you think that just to make it positive, we can just use a mod function, right? Even a mod would make this entire term positive. Okay. So why do we need to use a square? This we will discuss when we are talking about linear regression, but this is just a food for thought that just because we have seen that this would work, we shouldn't be removing all the other things. We should think about it and then we should use something optimal. But we should always think about what are the other possibilities and why this would work or would not work. Okay. I hope, yeah, this part is clear. Okay. So for today's session, I wanted to cover what machine learning is. I wanted to give a brief distinction between ML, DL, and AI. And I wanted to give you a thinking process when you should be thinking about using ML. That is the most important part. So I wanted to cover everything in close to 40-45 minutes that I have done. You will at least get a brief idea that what would be covered. And there is a doubt section there as well. So you have a doubt section at the top of the screen that you can actually send me a question. It's free of charge. You can send a question and I'll reply to those questions. But I would advise that before doing that, try to solve your doubts on your own because the journey of solving it is much important or much more important than the answer. So try to do it, try to discuss with your friends, faculty, and then we can discuss it.